Now we will discuss the most important topic of this chapter, that is hydrogen peroxide. Hydrogen peroxide. The physical property of this hydrogen peroxide are very similar to the water. This is also liquid. Boiling point is like comparable. It's 40 degrees Celsius, I think, difference, and it is 40% more denser. Okay. There are also some many significant differences, like you can never use H2O2 as a solvent. Why? Because it reacts with almost everything. It is a powerful oxidizing reagent. It is also a very powerful reducing reagent. Even if you keep this H2O2 in the open air, so with the radiation it will be dissociated to form H2O plus half O2. And this is the reason in the reagent bottle in the laboratory we keep H2O2 only in the dark bottle, and also in the dark bottle we do some waxing. Okay, so that with the help of that wax, H2O2 will not be come directly in contact with anything. Okay, otherwise it will be dissociated and it will give out oxygen gas. To decrease the rate of this reaction, sometimes we also add ethyl alcohol. So ethyl alcohol will be working as an inhibitor for this process. This H2O2 is having like many uses in daily life. It can be used as antiseptic. In olden time, people used to apply this H2O2 on any wound. Okay, so this H2O2, once it was applied, it started forming some foam. Okay, so people were they were expecting that H2O2 has now killing the germs. Okay, that was not the actually case. The thing is, H2O2, when it will be coming in contact with the blood, so in the blood there are enzymes, so that enzymes will promote this reaction. So H2O2, this will be breaking down to H2O plus half O2, and due to passage of this O2 gas, that foam was generated. So this H2O2 does not kill the germs, but what it does, it will give out that foam, and that foam in the form of that foam, this O2 gas will be released. So this O2 gas will be bringing out all the dirt or the dust particle inside the wound. Okay, so it can be used for cleaning of the wound, not for the killing the germs or not for the killing the microbes. Other use of this H2O2, that is as a bleaching reagent, because it reacts with unsaturated organic compound, and even in our skin there are organic compound which are unsaturated. Only those unsaturated organic compound in our skin, they absorb most of the light, and that's why our skin gets a particular color. So those pigments which give the color to our skin, they will be struck by this H2O2, okay, and they will be removed. So this is how this H2O2 also work as a bleaching reagent. And many Hollywood actors, they are like H2O2 blonde. Okay, so this is also one application of H2O2 as a bleaching reagent. One more question you can get from H2O2, that is its concentration. So we use a specific term to express the concentration of H2O2, that is volume of H2O2. Volume of H2O2 or hydrogen peroxide. So the thing is, suppose you have 1 molar H2O2 solution. 1 molar H2O2 solution. So 1 molar means there will be, suppose this solution is 1 liter. So there will be 1 mole of H2O2. So this H2O2 on dissociation, it gives you H2O plus half O2. This H2O is liquid, this is aqueous, and this will be gas. Suppose you have 1 liter, so in 1 liter you will have 1 mole, because this solution is 1 molar. So you have 1 mole of H2O2. So from 1 mole you are getting half mole, 0.5 mole. So at STP, this O2 gas at STP, this O2 gas will be occupying how much volume? 1 mole of any gas at STP that occupies 22.4 liter. So this will occupy 1 upon 2 into 22.4 liter, or you can say 11.2 liter. Okay, and how much was this H2O2? This H2O2 aqueous solution, this was 1 liter. So from 1 liter H2O2, this is in the liquid form, in the aqueous form. You are giving, this is giving you 11.2 liter oxygen in the gaseous form. So volume strength of this H2O2 solution, that will be 11.2 V. So what is the volume strength? Volume strength is how much gas at STP you obtain from a unit volume of a H2O2. Like if instead of 1 molar, if you have 2 molar H2O2 solution. Okay, so 2 molar like 2 moles in 1 liter. So again, if you take 1 liter solution, so there will be 2 moles H2O2 over here, and from 2 moles you can get, from 2 moles you will get here 1 mole of oxygen, because from 1 you are getting half, so from 2 mole you will get 1 mole of oxygen gas, and 1 mole at STP, that will be occupying 22.4 liter. So volume strength of that H2O2 solution, which is 2 molar, so 2 molar will be 22.4 volume. Okay, so there is one direct conversion as well. So volume strength will be 11.2 into molarity. Next thing, if somebody tells you a H2O2 solution is 10 volume, so what does this mean? It means at STP 1 liter H2O2 will give you 10 liter of oxygen gas. Okay, you can also write it as 1 ml H2O2 at STP, these calculations are at STP, will give you 10 ml of O2 gas, or 10 centimeter cube of O2 gas. Okay.